Hello and welcome. Another day and another Leetcode task. Let's see what we have today. Number of nodes in the subtree with the same label. Medium difficulty task. You are given a tree consisting of n nodes numbered from 0 to n-1 and exactly n-1 edges. The root of the tree is the node 0 and each node of the tree has a label, which is a lowercase character given in the string labels. The edges array is given in the form like this, which means there is an edge between nodes A and B, AI, BI in the tree. Return an array of size n, where ans I is the number of nodes in the subtree of the ith node which have the same label as node I. Number of nodes in the subtree of the ith node which have the same label okay, so okay, let's get back. Let's check these nodes at the bottom. 1 1 1 1. The node 2. The node 2. The subtree starting from node 2 has one node with a label, the same with this node, and this has two nodes. Okay, so here we have 1 1 1, actually 2 4. There will be 3 2 1 1 1. So the tree is quite big. Okay, let's see how we can solve this. Obviously, we cannot process the tree for every label. It will be too slow. We can try that to get a feeling of the task, but I guess it will be too slow. I think it may work going from the bottom up, calculating statistics along the way. Okay. So suppose we have an algorithm that processes a subtree like this small subtree. How can it be implemented? We need to calculate, when processing a subtree, we have to know how many nodes with each label below that subtree. we can build that information by going bottom up. It will be the first search, I guess, and using accumulated information to make new calculations. So let's suppose, okay, suppose we have a function that processes a node. That we will need, okay, type that will be a map of labels to number of nodes with this label. So when processing a node, we need that map. Actually, no. When processing a node, we want to return that map. This code doesn't work, but this is just pseudocode. It helps to think about the algorithm. Now we need to join these maps and return it. Not only that, we also have to collect the results. So the results is the array. Okay, so we need to join the map. Plus, we have to process the root node. So it will be like this. Actually, I think it will be byte, not turn. So we get the label for the node, for the root node. It will be 0 by default, and we increment it by 1. Also, we have to store results. So results for that node will be joint map labels node. Yeah, I think this is what we need. And yeah, this will work. Now let's implement this procedure. So first of all, we have to walk the tree correctly. It is the same problem as yesterday. We are given number of edges, and we have to walk the tree. Let's implement that. Okay. Connected nodes will be a map in bool. This is list of nodes connected to some other node. If true, the node connection wasn't used yet. Now we need to build edge map. This will be a map of a node to a list of connected nodes. Let's populate this edge map. We are checking and filling the map if the keys are missing. And now we add in the edges, the connections. Edge map from to equals true. It means the connection from node from to node 2 is available, and we also need connection from 2, but we also need a backward connection. Okay, we have the edge map, and now we will call the process node, and it will give us the results we need. Starting node will be 0. This is the root node. We need to pass the edge map, labels, and what else? And results, which will be accumulated. Yeah. So we need to accumulate the results. Okay, left map, right map. Well, is this a binary tree? Yeah, it is a binary tree. Okay. Yeah, I think it's better to do this way to make it a general case. We will process any number of child nodes. That will be easier to implement, less code. Okay. So we are going to iterate over edge map. Yeah, let's switch to the proper code editor. Okay, so we want to iterate all the child nodes. Okay. So what we are doing here is we want to prevent going upward. We want to go in one direction, only downwards. For example, when processing this node, we want to process these two, but not return back. So when going from this to that, we're marking this edge as used. So next time we're processing list of connected nodes, we will skip that. So edge map. Okay. The child node is not processed yet. So labels. So processing this child node. Edge map. Results. Now we need to join maps. So okay. Okay. Joined maps. Yeah, we join maps when we want combined results of all children. Yeah. Okay, joined map. Okay. Like that. At this point, joint map contains map of labels to count for all children. We need to add the color, the label of the root node. This one. And we need to store results. So results node. Actually, you know what? We need to make this an array, not slice. Actually, it should be the slice of size n. Yeah, okay. So we have results. And we can return the joined map. Labels. We have to pass all values through parameter list. We cannot use global variables. Global variables will not work on Leetcode. Okay, let's check this. I think the most complicated thing is this edge map and walking the tree. So starting from 0 and returning results. And here, labels map. Okay. Okay, the joint map will contain this mapping for all children. This is the list of child nodes, but not actually child nodes. It's not actually children. That's connected nodes. For example, for this node, we will get the list of 3, this. And we need to skip the edges we already walked. So here we have a label. Actually, that's not correct. It's not used already. It's available. If it's not available, then process the next connection. Actually, it's not children, it's connected nodes. But we already have this type. Okay, let it be connections. Okay, so marking the edge as used. So we are walking every edge only once and marking it as used in the process. we never have to walk one edge twice. So we get list of labels, точнее mapping of labels for the child node, and we are joining it to the combined array. So we are adding a label for the root node. We're storing the results for that node. And returning the combined map to use further. Well, it looks okay. Let's try to run it and see. Okay. Yeah, great. It worked. Well, the task was somewhat similar with yesterday's task. We have the same structure for the tree. I used the same algorithm to work with the tree. And yeah, I used depth first search. So we're processing the deepest nodes first. We are collecting statistics on these nodes when returning back. And here we use these accumulated statistics to get results and going again backward to the top nodes. Okay, thanks for watching. It was again a successful solution in half an hour. Well, thanks for watching and see you the next time.